Okay, so we're going to work on 1.7 perpendicular lines. Here's the IXL assignment, the homework assignment. Both have links on them, but they're also in the GeoMeto doc. But your objective is, I can understand and use perpendicular lines to find lengths of sides and triangles. So let's take a look. So what are perpendicular lines? Perpendicular lines are lines that cross each other at a 90-degree angle. So when you have two lines that intersect and they form a 90-degree angle, those are called perpendicular lines. Well, with that information, we can draw an example where you see XY is perpendicular to AB. And then the perpendicular bisector theorem is really what we're going to focus on. And if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So how we are going to look at that and what we are going to see is these kind of figures, where if you look, it says WY is the perpendicular bisector of AB. So they're talking about segment AB. So AB is limited in its distance. It is start and stop. It starts at A, finishes at B. And then the line WY comes through it and cuts it into two equal pieces and forms that 90-degree angle. So with that information, it's asking us, what is AW? Well, if I know BW is 27, then AW should end up being, why does it keep doing that? 27 as well. So I can say AW is 27. Okay? Then, if I know it's a bisector, it cuts it into two equal pieces. So AX is the same as XB. I see. So XB here, okay? So if XB is 18, then AX is going to be 18. Because once again, it just cuts it into two equal pieces. All right? Now, last one, if I have YW cutting through my AB segment and making a perpendicular bisector, now they're asking for A to B all the way across. Well, if that's the case, then we have to apply the segment addition postulate. The first piece is AX plus the second piece is XB equals the whole thing, which is from A to B. Okay? So I have AX plus XB equals AB. So once I fill that in, I know AX is 18. I know XB is 18. So let's substitute our values in. And if I do 18 plus 18, that will give me AB as a whole, which comes out to be 36. At this point in the video, pause it and try letter B. But once you have tried it, there you go. Double check your answers and make sure that those match up. So JM I know is 25, so JN is also going to be 25. MK, they want to know this side. Well, that's going to be the same as NK. So if NK is 15, MK is going to be 15. And then MN, you have to apply the segment addition postulate. 15 plus 15 equals 30. Okay? Let's try the next one. If BD is perpendicular to AC, so BD is a perpendicular bisector to AC. So then, if this side is 30, that side, we know, but we're looking for BC. Well, they said AB is 40, so BC should also be 40. And then DC is going to be the same as what's on the flip side, which is 50. And then AE is going to be the same as EC, so 30 and 30. And then the last one is AC, so we're going to go all the way across the map and get the segment addition postulate again. 30 plus 30 is 60, so AC is going to be 60. FC should be the same as FE. DC would be 5, or CD, depending on which direction we could go, here to here or there to there. Same distance either way. GE. Now, where are we going to get GE? Well, it does say, oops, my bad. So it does say FD is congruent to GE. So FD being 12 means that GE is also going to be 12. And then if we know this is 12, then we know the flip side is going to be 12 as well. All right. So the converse of the perpendicular bisector is a little bit trickier, and that's because we need to apply the Pythagorean theorem to this idea. Okay? So they told us because AD equals DC, therefore AC is perpendicular to BD. So AC clicking is way off. Okay, so AD is and DC, so therefore these two are perpendicular to each other. Well, if I know they're perpendicular, well, then I can utilize that, and I know it's a right triangle. So now I can apply the Pythagorean theorem. So once we know we have a right angle on both sides, we can apply the a squared plus b squared equals c squared to the right triangle. Okay, so I'm going to use Pythagorean theorem. I know my c value is always going to be directly across from my 90-degree angle, so my c value is going to be 10, and then a or b, you can intermatch, but we're going to do 6 squared plus b squared equals 10 squared. Therefore, when we do 6 squared, we're going to get 36. When we do 10 squared, we're going to get 100. So then if we solve for b squared, we're going to highlight b, draw a line down the middle of the equal sign, and we want to get rid of the number that's on the same side. So we have to get rid of 36 by subtracting 36 on both sides. So that 36 minus 36 becomes a 0. And then b squared equals 64. Take the square root of both sides. So we're going to square root both sides to get rid of the squared sign, so that I'm just left with b all by itself, and it's going to equal the square root of 64. And in turn, that is going to be 8. All right. I want to make sure everyone sees this solution. Pause it if you need to. Oh, my face is in the way. That's a bummer. Okay. So for this one, start with the first piece of information. The first piece, as I read this, says AC equals 12. So what does that mean if AC equals 12? Oh, thanks, Cam. That means from A to C, the measure is 12. Well, what can I do with that? Well, what is helping me know? Oh, well, I know AB and BC, because of those dashed lines, are equal to each other. So if the whole thing is 12 and it's 2 equal pieces, what does that mean? Well, it means each of those are going to be 6. So I've got a 6 here from A to B, and I've got a 6 here from B to C. So just starting off, all I knew was AC equals 12. I already know 3 different measures now. I know AC, I know AB, and I know BC. Next thing it tells us is QD equals 10. So I know this length right here, QD, is going to be 10. All right. Now, how can I start applying some of this information? Ooh, well, I know CD has a line on it as well. So that means that if this is 6, this is 6, this has to be 6 as well. Okay? Now, if a point is equidistant from the endpoints of a segment, then it's a perpendicular bisector on the segment. So if a point like Q is equidistant from B and D, which it is because this segment's the same length as that one, then I can use this. So Q is equidistant from B to D. So that means BD is perpendicular to QC. So I know this line is perpendicular to that line, which makes 90-degree angles. Well, if that's the case, now we can apply the Pythagorean theorem. So we can do a squared plus b squared equals c squared, and set that up as 6 squared plus b squared equals 10 squared. Now, I know this is where this slide ends, but I want you to think about it. What did we have here? 6 squared plus b squared equals 10. So make sure you can go through this and solve it out yourself without my help. But if you do need it, just refer back to the previous slide. All right, last one. So we have PB equals 3. Oh, I just gave the solution for this one. So give this one a try, but talk about PB being 3, AD being 12. So we're going to break it up and then find PC. So I did that, and when I know the whole thing is 12, that tells me that each piece here is 4. And then I know this is 3, so now I'm going to pull this triangle out. And then I'm going to do a squared plus b squared equals c squared. And once I set it up and solve, I get that c equals 5. Okay, so let's stop that.